Hi everyone, my name is Nandini. I'm an M5 staff member. That's Kobe, he's also an M5 staff member, and we both work with THD soldering training at M5. I'm a senior majoring in computer engineering. This is my first time teaching the workshop, so if I mess up really badly, just know it's my first time. So just to go over what THD and SMD is, we're going to be doing THD soldering, and this is the PCB. It's sort of what a THD soldering PCB looks like. And essentially the difference is that THD soldering secures components by placing the leads through like a hole and then applying solder to that hole. Whereas SMD, you'll see there's these like metal squares, and you secure the components onto the PCB by just like placing the component on the surface of the metal surface and then like applying solder by heating up that surface. It's a little bit more technical. I mean, it's a bit more complicated. And the advantages are this one is more secure because you're actually going to be like putting things through holes and soldering, so the connections are more secure. This one's a little bit less secure, but the components come in smaller sizes. So if you want like a more compact PCB, which often when you make like a final version of like your chip or something, you'll make it an SMD version so that it's like smaller. So you'll find it in this. So we're going to be doing this today because it's a lot easier and in my personal opinion a lot more fun. So what exactly is soldering? Go back a slide. So essentially soldering is joining metal electrical components together with a metal alloy called solder. It is not welding, and welding is just like actually fusing two components together to make it sort of like one thing. That's not it. We're just like joining two things together with like a metal alloy called solder. And yeah, this is sort of a demonstration of what soldering sort of looks like. So you'll notice like each of these holes has like a metal ring around the hole. So when you're soldering, you're going to be aiming to make a connection between the leg or the metal part of your component and that pad. So that's going to be essentially connected together with the solder. And then in the PCB, if you'll see it when you get the PCB, you'll notice these like lines connecting the different holes together. And those are called traces. And essentially what the PCB is it's like a compact version of the things you build on a breadboard, all those like things you connect with wires. The PCB does that in the PCB itself with all those like lines. So this is solder. This is essentially what it looks like. It comes like a little roll. And solder is mostly an alloy of like lead or tin. Sometimes it contains other metals like silver. We're not going to be using the solder that contains lead because the fumes that come from soldering, when you inhale them for a long period, they're bad for your lungs and can cause respiratory issues. So we're going to be using lead-free solder, and that's still not the best to inhale, so just try to like be careful, but it's much better for long-term health. And sometimes the other materials that can be in solder is like copper, silver, nickel, or germanium, and you can like find those informations like here. You can like see them. And then additional thing what we're going to be using is flux. So flux is a chemical that essentially removes the oxidized layer off of a metal. So when you're going to your soldering stations, you'll notice the soldering iron, like the tip is like really dark and like black. So that's essentially just like the oxidation layer on top of the metal. That's bad for soldering because that prevents connection. It's insulating the connection. So we want to remove all of that, and we use flux for that. So you'll see at your stations, the flux comes in the form of like a pen. So if you see that when you're trying to solder, the solder isn't really sticking, it may be because there's an oxidation layer either on the iron or like on the component itself. So you can just take some flux, put it on the joint, and then solder, and hopefully that'll help you make a more secure connection. And you can also, sometimes you'll find flux in the solder itself, and that's called rosin core solder. So it'll be in these like holes, these cross sections, and the solder can have multiple cross sections. So this is like a single core one, and that's like 5 cores. We have a 3-core solder. So essentially for today's soldering, you wouldn't need to have external flux because the flux inside the solder should be enough. But just in case, I just want to let you guys know that this is something you should use. Next slide. And safety. This is probably the most important part of this presentation, so be sure to pay attention. We don't want to be doing this, like melting our computers. So first important thing, make sure to wear your safety glasses. So solder can sometimes splatter, or when you're like stripping a wire, the wire strips can like get in your eyes. I've done it many times. As someone who's teaching safety, it's a little ironic. So make sure to wear your safety glasses. If you have glasses on, you don't need to wear safety glasses. It is optional. So just make sure to do that. We don't want anything to be getting in your eyes. Second, fume extractor. So as I discussed earlier, when you're soldering, the flux that you're melting can release fumes, and you want to avoid inhaling those because it's like a chemical. We don't want those getting in our lungs. So we use a fume extractor. They can come in two forms. Some stations have these. Some of the stations were getting these new fancy ones that look like, I don't know, some monster tube thing, I don't know. So just make sure to use those when you're soldering. You want to position them in a way that it's like sucking the fumes but not inhibiting your soldering. You don't want it to be getting in the way. And then third most important thing, which seems obvious, but you'll be surprised how many people like have done this recently. Don't touch the hot part of the soldering iron. I should have brought a soldering iron, but essentially, so the soldering iron contains like a plastic part and then a metal exposed part. The metal exposed part is what we're going to be used for soldering. The plastic part is where you want to be holding the soldering iron. You don't want to be touching that metal part. If you see a soldering iron that's not in its stand, never touch it by the metal part. Just assume it's always hot and always touch it by the plastic part. We do not want you to get hurt. It is very painful, and if you want to talk to some staff about how painful it is, they'll be able to tell you stories about it. So let's all not get burned today. Next slide. Yeah, I already went over this a little bit. Just beware of lead solder. M5 does not use lead solder. We use a lead-free solder, but if you go outside and work in like a lab for your internship or your jobs, you might encounter lead solder. I encountered it when I was working in my internship this summer. Just be careful, like when you're soldering, just take a quick look at the soldering like reel. It will probably say it contains like a hazardous substance like lead or something on the cover if it is lead solder. Just like make sure to double check that, and if your lab offers lead-free solder, try to ask them for it because you want to avoid lead solder as much as possible. The reason that lead solder was like pretty common was because it was pretty convenient to solder with. The melting point was low. It wouldn't crystallize that much. It would release less fumes. But we just want to steer clear of all of that because it is still dangerous for health. So we're just going to be using lead-free solder today. You can go to the next slide. So if you look at a joint, and we won't be looking at two different joints, but essentially this is the difference between lead-free and leaded. You'll notice leaded solder joints are much shinier, and a lead-free solder kind of has this like crystallized layer on top of it. So lead-free does release more fumes and does have like a higher melting point, but it is safer overall. And yeah, I kind of went over this, but this is like just some of the information that you can find about the solder, like the alloy, the diameter, like how big the solder is, the number of cores, and then the flux type. And yeah, next slide. So additionally, when you're soldering, you kind of need extra hands to like help you like hold the board, because if you're going to be soldering, you're going to be holding the soldering iron in one hand, the solder in the other hand. Who's going to be holding the board, because that's going to be hot. It contains like metal pads and everything. You don't want to be touching that. So we're going to be using like helping hands for that. So you'll notice this when you practically solder, but like you're going to be placing the PCB here, and that's going to help you like hold the PCB in place. And then you can use these arms sometimes to hold components together, because you don't want to be touching that when you're soldering. It's going to be really hot. You don't want to be touching any sort of metal when it's doing that. So just like use these sort of extra hands, pliers, any other tools that will help you like keep things in place for you so you don't have to actually touch it. Sometimes, you know, people like stick tape together. Don't actually stick tape over a component, but like if you're joining two wires together, you can tape the wires and like hold them in place. Just like find tools that help you hold things in place so you don't have to be touching them. Just a little bit about like how the station should look. This is the fume extractor we discussed earlier. You want that positioned in a place where it's like close to your board, but not in a way that's like blocking your view. And then you want the soldering iron and stand to be on the side of your dominant hand. because you're going to be like using it kind of like a pen, so you want it to be on the side that you use your hand the most. And the solder is going to be on the opposite side. You want to make sure other tools, paper, anything that you're not using for soldering is like out of the way. Okay, another important thing. Remember how I mentioned like soldering irons can develop this oxidation layer on the top, which is why they'll be like dark, and that's bad for soldering. So in order to prevent that, and also this is for maintaining the tip of the iron, we do a process called tinning. So you do tinning, and essentially what tinning is, essentially you take this hot iron, you just feed solder to it, and then you like place it in this copper brush and like spread the solder all over it. So now the solder is covered all over the tip. You'll see it's like shiny now. And that essentially just makes sure that we're like maintaining good contact with the components when we're soldering. And additionally, another way of cleaning the tip is you can either put it in this copper brush, which I discussed earlier, or this sponge. Now, what I want to emphasize with the sponge is dry right now at the station. If you're going to be cleaning your tip using the sponge, you got to make sure it's wet, because otherwise it's just going to pierce a hole in the sponge, and we don't want sponges with holes in them. So there should be stations with water at every soldering station. Sorry, bottles with water at every soldering station. So just like squirt a little bit of water, make sure the sponge is like nice and wet, and then dip your iron into the sponge. Don't do it while it's dry. The importance of tinning is that if you don't tin, you'll notice it turns black, and it becomes really, really difficult to solder. And then after a few weeks, if you don't continue to tin it, the tip is gonna really deteriorate, and then we're gonna have to get new tips. So really maintaining the tip is in your hands. Just make sure to do it. It's not like a super stressful thing. Don't worry about it if you forget it, but just make sure, like if you're soldering, remember to tin your tip. And yeah, when you're not using the soldering iron, just make sure to turn it off when you're done. We're using Metcal's. So Metcal's has this really cool feature. When you place the soldering iron in the stand, it automatically enters this like low power mode. It doesn't switch off, just enters like a low power mode, which is at like a lower temperature. So that helps like maintain the soldering iron, because if the iron is constantly at a hot temperature, it does create that oxidation layer. So you just want to make sure we take care of our soldering irons like everything else. Okay, so the technique for soldering. So what you're going to do for through-hole soldering is you're going to place your components' legs in these like holes wherever the assigned holes are supposed to be. You'll find in the PCB it very clearly states which component should be in like which holes. And then you're going to, on the opposite side where all the metal pads are, you're going to heat up the pad using the soldering iron and then feed solder to the joint. What you don't want to be doing is feeding solder to the iron and then like drawing or like painting over it. That's not going to work, because the solder is going to go to the hottest thing on the board. You want to make sure that the joint is as hot as the iron. So you're going to place the iron on the joint, then feed the solder to the joint. It might not make much sense now, which is totally understandable. You'll like get a grasp of it the more you do it in the pie room. And then yeah, once you're done, just like inspect the joint, make sure the entire hole is covered. You don't want any gaps there. And if you go to the next slide, I think it shows, yeah, a good example of a joint. So it's completely covered and it starts to like form this little like conical structure. You don't want too much solder. There's no example here, but it sort of like starts to form like a ball around the joint. So you just want enough that it like covers the hole, but also just like starts to form this like little cone-ish thing. And the more you do it, the more you'll be able to judge like what a good joint is versus what a bad joint is. And then cleanup. Again, pretty straightforward. Just when you're done soldering, make sure to clean up all your tools, put them all back, switch out the soldering iron and the fume extractor, put all your safety goggles back, and just leave it as clean as it was when you came, so that the next person who solders will be able to use the station. So now we're going to be starting to arrange our components on our PCB. We're not going to start soldering yet. Just because we've seen that it takes a little bit of a long time. What we're going to do is place the parts on the PCB first, and like we're going to show you how to do that, and then we're going to go and take it and solder it in the pie room. So first, we're going to start with our resistors. So the way you put your resistors, and this is a proto board, our PCB is going to look a little different, but you place the two legs in holes, and you're going to secure it by bending the legs in the opposite direction. Now, why do we do that? Because you're going to be soldering on the opposite side, and the entire thing is going to be upside down. So you don't want the component to be falling out while you're doing this, so you're going to bend the leads in the opposite direction so that the resistor stays in place while you're soldering on the opposite side. So Kobe's going to hand you your PCBs and your components shortly. If you don't have a kit, raise your hand. Yeah. So for the color schemes for the resistors, I don't know if all of you can see it. I can write it over there. But the 100 ohm, the color pattern should be brown, black, brown. The 2K 2 ohm should be red, red, red. And the 10K ohm should be brown, black, orange. Okay, awesome. So we're going to move on to the polarized components. So for these components, which are essentially the ones where like you have to be careful about the positive and negative leads, so you want to make sure that they're correctly oriented. Let's start with the capacitors, which is C1, C2. And then once you've done your capacitors, you can move on to your transistor, which is Q1. Okay, so the next thing we're going to be talking about is the IC. So the IC, the legs are a lot shorter, and you can bend them the same way that you've done the resistors and the capacitors. And additionally, we're going to be using sockets to hold the IC in place, so we'll go over that more in the Pyro. But yeah, once everyone's done their transistors, resistors, and capacitors, we can grab your schematic and your diagram and the list of components, and then